Hello my dear students, I welcome you to NEET World. So we will be continuing our session on 100 days challenge for upcoming JEE, NEET and EAP-set entrance exams, right? So let us discuss about this redox reactions. So what exactly redox reactions? So tell me. So here the name indicates what? The name redox indicates what? Reduction plus oxidation, right? So here it is a combination of two process. One is reduction and other one is oxidation. So those reactions in which both reduction half and oxidation half are involved are considered to be redox reactions. Okay, so now these are generally we'll be seeing these reactions when a metal and a non-metal is reacting. What happens? So generally metal loses electrons that will be taken by non-metal, right? So now what happens? The species which is losing the electrons, we can consider it as what? Oxidation, that is undergoing oxidation, and the species which is gaining the electron is considered to be undergoing reduction. So now let us look into the what exactly the definitions for this reduction and oxidation process, okay, and we'll understand it more clearly. So once after understanding these redox reactions, yes, so from this chapter we can directly expect one question, and also the interlinking of this chapter with electrochemistry, there also you can expect one more question, okay. And you know, this is one of the most important and basic topic which you need to understand in order to gain some clear cut idea on this chemistry reactions, okay. One is mole concept and this redox reactions are the two important chapters one should know if you want to master the chemistry topics from physical chemistry especially, okay. So now here I wanted to explain what exactly oxidation and reduction here it will itself will discuss. See, reduction means what, oxidation means what, let us discuss. So reduction means what? So in terms of oxygen, for example here I have a reaction, okay. So for this reaction let us see A and B are the two elements, okay. So now here I can say oxidation reduction in terms of electronegativity, okay. So now what I told you, metal and non-metal I have told now. So generally non-metals are more electronegative and metals are electropositive, okay. So electropositive species, what they will do, they will be releases electron and they will exist in the positive nature, right, okay. So now if I say A is electropositive metal, what it will do, it will lose electron and it will form respective cation, okay, and that whatever the lose electron will be taken by this B, okay. Let us say it is losing one electron, it is gaining one electron and forming AB type molecule, okay. So now the species which lost electron will be in the cationic charge, right. So now that species I can say, this species I can say it is undergone oxidation, okay. What is that? Oxidation, okay. Now the species which gain electron, see B becoming B minus. So now this species is what? B is undergoing reduction. So its oxidation, its number, whatever the charge here you are seeing, so that number is reduced now. So B from 0 state to -1 it is becoming. So this process is called reduction. Hope it is clear what exactly oxidation and reduction in terms of electron gaining and electron losing, right, okay. Now I can tell you the same concept in terms of others also. I mean, for example here you can see for element A I am adding oxygen. So addition of oxygen, what is that? Addition of oxygen is called oxidation. So to this element I am adding this oxygens, so it will become, let us say AO2 it is becoming. So now this is what? Addition of oxygen. So addition of oxygen is called addition of oxygen atoms, okay. So this process is called oxidation. For example we have magnesium, okay, it is a metal, okay. To this I am adding oxygen, okay, O2 here, okay. So we know metals, this oxygen is non-metal. So generally what I told you, metals are electropositive, it loses electron, that is taken by oxygen. In this way also you can understand the like what exactly oxidation and reduction. So now what it will form? Magnesium oxide. Okay, so magnesium oxide. So this process is what? So addition of oxygen to this magnesium is a oxidation process. Okay, so now here we require 2 magnesium. That's it. Hope it is clear. Now here if I say removal of, for this the opposite should be reduction, I can say. So here I can say removal of oxygen is called reduction. So for example, I have something like AO. So A is an atom combined with oxygen. So from that, so this is, let us say, so from this I am removing oxygen. Okay, so I can remove either 1 oxygen or 2 oxygen, but at least you need to remove some part of oxygen at least. Okay, so removal of oxygen, let us say 2 oxygen atoms are removed from here. So this is what? It is also what? Reduction. Or I can remove at least 1 oxygen, partial reduction I can say. Like this also I can remove. So this is also what? This is also what? Reduction process only. Hope it is clear now. Yeah. So now next, this is in terms of like addition of oxygen, in terms of oxygen I am saying. Now in terms of electronegative atom also, you can write addition of electronegative atom. So we know oxygen is also electronegative atom. So in that way also you can addition of electronegative atom. I can also say this is also oxidation process. For example, to the same magnesium, see I am adding this chlorine. So what will be the product? MgCl2 will be the product. Or to the what I'm saying, to the magnesium I have shown you, to the sodium atom, let us say. So to the sodium atom, okay, I am adding chlorine. So it will become what? NaCl. So this process is also what? Electronegative atom is added to the sodium now. So it is also what? The oxidation process here. Okay, so here 2 sodium you can say. So here what I can write? Removal of electronegative atom. Removal of electronegative atom is what? Reduction. You can understand. Hope it is also clear. Right. Now let us move further. Now let us talk in terms of the hydrogen atom. Okay, so here removal of oxygen is called a reduction, addition of oxygen is called oxidation, I told you. So now here addition of hydrogen atom, what I am saying, addition of hydrogen atom is what process? It is reduction process. Okay, so now let us say here we have let us add something, carbon. Okay, so to these carbon atoms, let us say we are adding hydrogens, or let us say we have CO or anything. So to this carbon, let us say we are adding hydrogens. Okay, so this whatever addition we are doing here, so we are doing it is converting into methane, right? So this process is what? To the carbon we have added hydrogen, it is become something like a methane or some product we are getting, hydrate we are getting. So now this compound is what? This process is what? Carbon undergone reduction. Why? To the carbon we have added hydrogen and it is forming a hydrate. Okay, so now what is this? So this is a reduction process. Okay, now for more clarity I will be telling you one more thing. See here we have carbon, on this we have oxygen, to this we have one hydrogen. Now I can say these are called carbonyl compounds. What are those? These are carbonyl compounds. To this I am adding hydrogen atom. Okay, so if I represent like this in the square bracket hydrogen, you can consider it as a nascent hydrogen. Simply we can use parenthesis bracket like this, something like this. Okay, so this process is what? We are adding hydrate ion to this carbon. Okay, so now this will be added over here and it will be converting into like this. Okay, so here we have added one hydrogen. This hydrogen is nothing but this one. Okay, so this hydrogen is added on to the center carbon now. So this addition of hydrogen is what? Reduction process. And now the species which giving this hydrogen atom should be called as reducing agent. What is that species? Reducing agent. Generally here we will be using something like lithium aluminium hydride, sodium borohydride. These are the reducing agent generally we will be seeing in the organic chemical reactions. So these carbonyl compounds, upon treating with reducing agents like sodium borohydride, lithium aluminium hydride, like this. Okay, so that converts this oxygen like this carbonyl carbon into the alcoholic form. Okay, we have an alcohol as a product. So this process is what? This process is what? Reduction. Okay, addition of hydrogen. Hope it is clear. Now the reverse of this, I mean what I can say? What I can say? Removal of hydrogen atom. Okay, it means reverse of this. For example, here what is this process I told you? This is reduction I told you, right? Okay, so reverse of this means I wanted to convert this alcohol to this aldehyde. Okay, so it means I wanted to remove this hydrogen from here so that we will get this aldehydic product or some carboxylic acid product. So in this case what we are using here? So we will be using something called oxidizing agent. What we are using? Oxidizing agent, and the process is called oxidation. Okay, so these oxidizing agents are something like PCC, pyridinium chlorochromate, something like you will study this in the organic reaction. Just now you just write this as an example. So now what is this process? Oxidation, you can write oxidation. Okay, hope it is clear. Now everything, if you add hydrogen you are saying reduction, if you remove hydrogen you are saying oxidation, if you add oxygen you are saying oxidation, if you are removing oxygen you are saying reduction. That's it. These are the things you need to remember. Hope it is clear what I am talking here. Now one more last definition we have in terms of electrons. So addition of electrons is reduction process. What is this? It is reduction. Okay, now addition of electrons is reduction, and now here I can say removal of electrons is what? Removal of electrons is oxidation. So these are the terms you need to understand. Okay, so now let us understand what exactly addition of electrons. See, I am writing a reaction here. Sodium atom, so here there is no charge on sodium, so we can say this is an atom. Now I am treating this with chlorine. Okay, so what we are treating? Chlorine. We are adding chlorine to this. Okay, so now what happens here? See, sodium chlorine, so it will form sodium chloride like this, NaCl. Okay, so during this process what happens here? So sodium atom will be converting into sodium ion, so it is forming a cation like positive charge. So whenever a species is having some positive charge like +1, so you can understand that it lost one electron. If it is having +2 charge, then you can understand that it lost 2 electrons. Okay, like that. Whatever the positive charge number, so that many electrons it is losing here, you can understand like that. Now chlorine here we have, this is molecule, now converting into chloride ion. Here chloride ion will be with -1 charge. Now chlorine molecule converting into chloride ion. See, now chlorine is having -1 charge. So what does it saying? So it means this chlorine gained 1 electron and becoming Cl minus. The negative charge with one number indicates what? That many electrons it gained here. Okay, so if a species is having something like -2, it means it gained 2 electrons like that. Okay, so now what we have studied, addition of electrons, or I can say simply gain of electrons is what? Reduction. So which is gained here? Electrons. Chlorine is gained electrons, no? So we should call this as reduction. Okay, so this half reaction is called reduction. Now sodium atom having 0 oxidation state converted into Ca+. So this process is what? So it is converted into cationic form. So now what I can say, it lost electron. How many electron? 1 electron by each of the sodium atom. So loss of electrons, removal of electrons or loss of electrons. What is that process? Oxidation. That's it. Like this you have to understand. Okay, so now in a chemical reaction both oxidation, reduction are involved. So overall reaction can be given or considered to be it is an example of redox reaction. Hope it is clear without any confusions, right? So if there is no confusion, please click on the like button, and if it is clear, just click on the like button so that I can make that you are clear with my explanation here, right? So now what is the next thing that we need to know here? So we need to know about oxidation process. See, oxidation number. So what exactly oxidation number and why we need to study? See, you have studied here what is mean by reduction and oxidation, right? So now oxidation means loss of electrons, you are saying now. So now when an element combined with other elements to form a compound, now how many electrons gained by that element, or how many electrons lost by that electron, by that element in that molecule, we need to understand now. So for that we are expressing in terms of its oxidation number. So what is this oxidation number? It is a arbitrary charge, or it is a imaginary charge, present on an atom of an element in its free state or combined state. So free state means when it is existing freely without combination with any other species, and combined state means when it is combined with other elements to form a compound. In that case, what is the charge present on it? That is what I am saying here. So now let us say here, I told you just now the basic example here we have taken. Magnesium combined with oxygen and forming magnesium oxide. This is what we have seen. Now here magnesium, it is not combined, initially it is not combined with anything. When we are taking magnesium alone, it will be like this, magnesium ribbon, let us say. So that will be like this. So it is not combined with any other elements now. So here there is no charge on it. So 0 is a charge we can consider. So now I can say its oxidation state, any element in its pure state or in its elemental state, the oxidation state will be 0. Okay. So now what do we mean by oxidation state? It is an imaginary charge that is present on an atom. See, that is present on an atom in its free state. So I can say it is 0 for magnesium. Similarly for oxygen also, these oxygen atoms are, it's a molecule. Molecule means here it contains diatomic molecule now. So it is a 2 atoms containing molecule. So both are same elements now, oxygen. So the oxidation state, there is no electronegativity difference now between oxygen and oxygen, right? So in this case what, that overall net charge will be 0. So what is the charge on the element? If it combines with itself, it is also 0. Now this magnesium combining with this oxygen forming magnesium oxide. We know the electronegativity of, see, the oxidation state, oxidation number, this concept is completely what? It will be depends on electronegativity difference. What is that? Electronegativity difference. Okay, this is one of the major criteria we need to consider. Now out of magnesium and oxygen, which is more electronegative? We know electronegative atom here is oxygen, and we know magnesium is metal which is electropositive, right? So now it will be having +2 charge and it will be having -2 charge. Okay, so now the one which is having positive charge, I can say it is what? Underwent oxidation from 0 to +2. So this oxidation, this is reduction. Okay, hope it is clear. Now what is the oxidation state of magnesium? If they ask, you should say +2. So how we got this +2? See, magnesium, okay, oxygen we have. In this case, now tell me how many valence electrons are present with magnesium. See, its atomic number is 12. So it will be having neon gas configuration, that is 10 electrons are over. After this inert gas configuration, we have 3s2 electrons. These are the extra electrons which are present with the magnesium after fully filling its stable octet or stable inert gas configuration, right? So now here oxygen is atomic number, we know 8. Okay, its atomic number is 8. So it is having how many electrons? 2s2, 2p4, 6 electrons it is having. Now in order to get octet configuration, that is 8 electrons. Now in order to fulfill its 2p orbital, and become a neon gas configuration. How many electrons it requires? It requires 2 electrons. Na? So it has, oxygen has more tendency to gain the 2 electrons. Now from where it will gain? It will gain from the neighbors. See, who is its neighbor? Magnesium is its neighbor. Now it is having these 2 electrons which are extra, means what? Which are more than this stable neon gas configuration. Now it is ready to donate the 2 electrons and it is also required the 2 electrons. So it has tendency to take the 2 electrons. So that these 2 electrons are taken by oxygen. Now it will becomes what? After taking 2 electrons, it will become O minus 2. And what about magnesium? It loses these 2 electrons and will become, and it will become what? It will become magnesium plus 2. This is what you need to understand. Hope it is clear. Now what is the charge present? The arbitrary charge, the imaginary charge present on magnesium is plus 2 and for oxygen minus 2. Now it is what? It is purely depending upon the electronegativity difference, the species or the ion or the molecule or the atom which is having more electronegativity in the combined form, that will drag the bonded pair electrons towards itself. For example, here for understanding purpose, let us take one more example here. I am taking carbon attached with the oxygen, it is attached with the hydrogen, and this side it is attached with one more carbon, let us say, like this I am writing. Now we need to identify the oxidation state of each of these elements. So how can we assign the oxidation state? Okay, so there are some rules that we need to follow. Okay, so now I will be telling you, all these rules are just based on the electronegativity difference only. Let us understand that. See here, between carbon and oxygen, which is more electronegative? Oxygen is more electronegative now. So now take these 2 bonds, remove these 2 bonds towards more electronegative atom. See, we know oxygen is more electronegative atom now. So if these 2 bonds are taken by oxygen, so now what is the charge oxygen will get? So 2 bonds are taken by oxygen only now. So these, see, these 2 bonds are formed by 2 electrons from oxygen, 2 electrons from carbon, right? So total 4 electrons. So now these 2 electrons are oxygen, that is fine. 2 more electrons are taking from the carbon towards the oxygen due to its more electronegativity. So that oxygen will get what charge? Minus 2 charge. So that will be the oxidation state of oxygen. Hope it is clear. Now if it is clear, just click on the like button, and if you have any queries, feel free to ask in the chat box. I am looking into the chat box, that like comment box, so you can write there. Okay. Now these 2 bonds are taken towards oxygen, so it is having minus 2 charge. Now what about carbon? So all the electrons are moving towards oxygen now, so it should have no plus 2 charge. Okay, these 2 electrons of carbon is taken by oxygen only when we finding the oxidation state. Okay, so it means carbon should get positive 2 plus 2. Now here between carbon and hydrogen, which is more electronegative? Carbon atom. Now therefore the bonded electrons, these bonded electrons are moves towards carbon side. Now hydrogen should get positive 1 and carbon should get negative 1. Hope it is also clear. Now if you look, this carbon atom and this carbon atom, which is more electronegative? Yes, tell me. So here it is having sp2 and this is what? sp3. So this is what? sp3. Okay, so this is sp3 and it is attached to the 3 hydrogen atoms here. 1, 2, 3. Okay, so this carbon is sp2. Okay, so otherwise let us study about this sp and sp2 hybridization later. Okay, now I hope you got the clarity between, just remove this, so just understand up to here. So I hope how I have separated them based on their electronegativity differences. Okay, so now out of this, what is the net oxidation state present on this carbon? So forgot about this carbon, let us keep it aside. Okay, now tell me, what about the net charge? Plus 2 from oxygen, minus 1 from this hydrogen with respect to hydrogen. Overall it will be plus 1 from these 2 bonds. Now what is the net charge, net oxidation state of this carbon? It will be plus 1. Hope it is clear. That is, this center carbon is having plus 1 oxidation state, this hydrogen is having again plus 1 and this carbon is having minus 2. Okay, hope it is clear. Now about this carbon, this side carbon I will tell you later, because there is again the concept of hybridization also. We'll take that in the after some time, okay, or upcoming slides, okay. So here I am adding hydrogen here also. Now in this case you tell me again which is more electronegative. Carbon is more electronegative, no? So hydrogen will be positive, this carbon will be negative. So how many negatives are there? This side one negative, this side one, with respect to this bond also one more negative for carbon. So positive with respect to these two bonds and negative with respect to these two bonds. Overall net charge will be 0, right? So now what is the oxidation state in this case? For the central carbon it will be -1 from here, -1 from here, +2 from here. So it will be -2 +2. Overall will be net charge will be 0. Now what is the oxidation state of center carbon in formaldehyde? It should be 0. So it should be 0 here for this. Hope it is clear how we are studying this kind of things, right? Now let us move further. So there are some rules. So what are those rules? See, whenever these rules based on what? Electronegativity only. So most electronegative atom always give -1. Okay. So in the element like in the combined state. So if we are looking into different forms, like let us say A, B, C are the different elements we have. Now out of this, which is more electronegative? Let us say C is more electronegative atom. So C should have the negative charge and more electropositive should have positive charge. So like that. So fluorine, we know this is the highest electronegative element in the periodic table, so that it will always be negative charge, -1 with respect to halogens, and especially for fluorine it should be always -1. Okay. Then next, oxygen will be having -2 charge. The first most electronegative element in the periodic table is fluorine and second most electronegative element is oxygen. Okay. So now whenever oxygen combined with any element other than fluorine, take oxidation state of oxidation charge with respect to oxygen as -2. Okay. Any element other than fluorine and also other than with itself, oxygen with itself. Hope it is clear. Now I will be telling you why it with itself, because these are the 3 other scenarios you need to know. So now what I told you, let us say oxygen attached with the hydrogen atoms. Okay. Now let us say it is forming water molecule. Now what is the oxidation state of oxygen in this compound? Yes, I told you fluorine is the first most electronegative element in the periodic table, after that oxygen. It means definitely oxygen will be more electronegative element than this hydrogen. Therefore oxygen, hydrogen we have like this. So electronegative atom here is oxygen. So these bonded electrons taken towards oxygen. So -1 with respect to this bond, +1 on the hydrogen. And here also -1 with respect to this bond, +1 on this hydrogen. So oxygen oxidation state is how much here? O2 minus. So oxidation state of oxygen is -2. And what about hydrogen? It is +1. Hope it is clear. Like this you need to write the oxidation states for each of the element. Okay. Let us understand few more things here. Okay. Now I have attached Cl2O. In this case you tell me which is more electronegative, and also you need to understand one more thing, F2O. You need to understand these two things here. Tell me which is electronegative element out of these two. We know oxygen is electronegative than the chlorine, right? Okay. Electronegativity difference I am saying. Since electronegative atom is oxygen, so the bonded electrons moves towards which side? Which side it will move? Towards the electronegative atom, that is this side, oxygen side. So chlorine should get positive charge, oxygen should get negative charge. Here also. So how much charge? So bond, if one bond, 1 minus, 1 plus. 2 bonds, 2 plus, 2 minus, something like that. Okay. So this side one more bond, so -1 plus 1 this side. So what is the oxidation state of oxygen here? -2 you should say. What about chlorine atoms? Chlorine atoms is +1. Hope it is also clear, right? Now tell me in this case, tell me here in this case, so which is more electronegative here? Electronegativity of fluorine is greater than oxygen, right? So now oxygen, fluorine we have, right? So in this the bonded electrons moves towards which side? The more electronegative side. More electronegative is fluorine atom. So -1 on each fluorine like this, So since bonds are moving towards the fluorine atoms, it will get +1 from this side, and here also +1. Overall charge present on oxygen is +1, it will be +2. This is the oxidation state of oxygen in OF2 or F2O. Hope it is also clear. Yes, if it is clear, please click on the like button once again. Yes. Yeah. So you can feel free to ask your doubts, express your concerns in the chat box, so that we'll address those first. Okay. Next. Now tell me, for this case, O2 F2. So what about this? How can we find? Okay. So in this case, I will be giving you the formula type of explanation. See, we know out of these two which is more electronegative, fluorine. So how many fluorine atoms are there? 2 fluorine atoms. So for each fluorine require 1 electron, therefore it gets their octet configuration, no? Inert gas, nearest inert gas configuration. So therefore each fluorine will be having -1 as a charge. Okay. So plus for oxygen we need to find now how many are there? 2. So 2 into X you can take. Overall molecule is neutral now, so let us take it as equals to 0. If it is neutral, take equals to 0. If it is positive, take equals to positive. If it is negative, equals to some negative sign you can take. Okay. So 2x equals to, so -2 here you have now, so you can write here +2. So remove these two things. So what is the value of x? It will be +1. Hope it is clear how we are solving this kind of questions. Now what is the oxidation state of each oxygen? It will be +1. Right. Next, now here we will take one more concept. The concept of oxidation states of oxygen in different formats. For example, here sometimes oxygen, see, generally what we told, oxygen atom will be negative -2. So whenever you are seeing oxygen with 2 minus, oxygen atom having -2 charge, so you should say this as oxide. What is this? Oxide. Okay. So whenever oxygen like see oxygen, see if it is O2 you can say oxygen molecule. If it is oxygen just O, it is oxygen atom with a 2 minus charge, you should say oxide ion. Okay. So this oxygen molecule can exist in two forms. One is O2 -2 like this and O2 -1 like this. So whenever it is in -2 charge, you should say this as peroxide. What is that? Peroxide. Okay. Whenever oxygen with molecule with -1 charge, you should say this as superoxide. Okay. These are the things you should remember. Now you know hydrogen peroxide now. So what is the formula of it? So H2O2, right? So H2O2. Now what is the oxidation states of oxygen here in this case? So we know electronegativity of oxygen is more than this hydrogen, therefore 2 into each hydrogen you should keep +1 charge. Okay, +1 charge, plus 2 hydrogens are there, so that's why 2 into +1. So 2 oxygen atoms. We don't know the oxidation state of oxygen, let us say into X I am writing. Overall molecule is neutral, so equals to 0. So now 2x equals to how much? 2x equals to, see this is +2 now, send that side, it will become -2. So this will be x equals to -1. So for each oxygen atom here in this case is -1. So for 2 oxygen here it is -2. So I can simply write oxygen like this, or I can write O, like I can write like this, each one -1 charge. So whenever in the superoxide they have given, peroxide they have given, and if they ask you what is the oxidation state of each oxygen atom, you should say it as -1. Okay. And superoxide case, for example potassium superoxide like potassium oxide like KO2 they will be giving. So we know alkali metals, see alkali metals like lithium, sodium, potassium, rubidium, cesium, belongs to which group elements? First group elements. Na? So what is the general electronic configuration? It will be NS1. For lithium 2S1, for sodium it is 3S1, like that. Only this one electron is extra with them. If they lose this one electron, they will become a noble gas configuration, right? So now always remember, alkali metals will exist in what state? With a +1 oxidation state by losing this one electron, and if it is having +1, so the oxygen will be having O2, will be having O2, overall it will be having -1. So for each one oxygen atom is how much? O if I consider separately, so it will be having 1/2, the other atom also having 1/2. This is the charge on each oxygen in the superoxide. What is the oxidation state of superoxides? In the oxygen oxidation state, it is -1/2. You should answer. Hope it is clear, right? Yeah, let's move further. So hydrogen atom, how much you should remember? It will be +1 in all the cases when it is attached with the other element which is more electronegative than that. Okay. Now metal hydrides. Let us say I have sodium. Okay. Now these attached with the hydrogen. Now tell me which is more electronegative. Sodium is electropositive. That's why I am saying alkali metal, highly reactive. So always remember, alkali metals, whenever they are combining with anything, always remember sodium metal, alkali metals will be in their +1 oxidation state. If they are in +1 oxidation state, they are losing one electron, that will be taken by this hydrogen. Okay, now hydrogen will be in the form of H-. So I can say this ion as hydride ion. Okay, what is that? Hydride ion. So for overall molecule I can say sodium hydride here, and the generalized what is metal hydrides. In metal hydrides, oxidation state of hydrogen will be -1. Hope it is clear. Here is how much? So here hydrogen will be -1, here also it is -1. Potassium is +1, here also it is +1. Hope it is clear, right? Right. So I hope you are following the class, especially those who are in live. Paliwal, I hope you are following the class, right? Next, let us move further. So halogens, how much it is? General one is -1. Fluorine is always -1. Fluorine will be always -1. So for chlorine, bromine, iodine, if it is attached with the more electronegative atom like oxygen or fluorine, in that case the chlorine and bromine will be having what? Generally they will be having positive charge. If it is attached with the less electronegative atom, then that it will be having negative charge. This is what you need to understand. Let me tell you one more example. Ammonia, simple example I am writing ammonia. So now tell me what is the oxidation state of nitrogen here. We know nitrogen is more electronegative than this. So 3 hydrogens are there, each one with +1 charge. So nitrogen, let us say X. So 3 hydrogen, 3 into +1 each hydrogen. Okay, 3 into 3 plus 1, 3 into +1 I am writing. So overall molecule is neutral. So I am taking it as 0. So N value will be how much? The oxidation state here will be -3. Hope it is clear how easily we are solving this kind of questions, right? Right. Next, so now whatever the things that you have studied till now, I have explained all the statements. Now I will be providing you few examples and you need to calculate their oxidation state, okay, and you have to tell me in the comment box, okay, so that when we are coming up with the next session, in that session I will be explaining this as a questions as which I have given as homework. In those sessions you can cross verify in that particular session. So solve these 2 questions, okay, and tell me the oxidation states of the sulfur atoms here. Okay, this is a JEE advanced question previously asked, JEE advanced. Okay, I will tell you, okay, about that. Okay, here also for chromium also you should say, and here for sulfur you can say. These are special structures you need to know, okay, and you can also find this basic one, H2SO4, what is the sulfur oxidation state, and the next KMnO4, what is the manganese oxidation state here, okay, and you can also write K2MnO4, Here also manganese oxidation state. You have to tell me this underlying atoms oxidation state. Okay. Here also sulfurs. This sulfur. Okay. And in this case, now read this question. One which is having, which are the following component, which are the oxygen has a positive oxidation state. Okay. So tell me in these 4, I have explained this question also. So you can give a try from your side and tell me answer for this as question number 3 in the comment box. I will be looking into it. What is the answer for this? You can also find these answers for these questions. So about these answers I will be discussing in the upcoming session. Whatever you have followed till now, based on that you can give a try to solve. Okay. So thank you for watching. Happy learning. Stay connected with us.